Adding, subtracting, and multiplying radicals. That we know the rules, we can practice them, and what we don't practice, we'll forget. So, let's look at the steps we're going to follow. Step 1 is that we're going to simplify the radicals first, before we do anything else. So step 1 is to simplify. Then we're going to identify radicals with the same, what? Index. That means that it's square root, cube root, fourth root, and it also has to have the same radicand. Shh, my video. That means root 2 plus root 3, it's not going to happen. They have to be the same index and the same radicand. They got to match exactly, and then you can add the big numbers or subtract the ones that are in front of it. But if they don't match, then you can't. But you don't know if they match or not until you simplify them. So for common radicals, you add and subtract the coefficients. Those are the big numbers in front, and then keep the common radical. Let's see. Number 1, both of them are square roots, but they don't have the same radicand. Like one's 27 and the other is 12. So first we have to simplify, and then we can see what we can do. So do you know how to simplify the square root of 27? 27 is, and 12 is, either way, right? And I always try to start with the perfect square, right? If I can. Square root of 9 is 3 times 3 in front is 9. Square root of 4 is 2 times 2 in front is 4. And then, do they have the same index? Do they have the same radicand? Right? Those are great words. They match, right? Root 3, root 3. Don't make me call you out in the video, right? So what's 9 take away 4? Done, right? Do you notice we don't add or subtract what's in there? Number 2. Do they have the same index? Okay, so let's simplify it. How would I simplify the cube root of 54? What perfect cube goes into it evenly? 8 times 6 is not 54. So what is the perfect cube that goes in evenly? 27, and it's 27 times 2. The next one is prime, and then the next one. Now, what is the perfect cube that goes into negative 16 evenly? 8, right? Negative 8 times 2. All right. So first we simplify it. The cube root of 27 is 3, and 3 times 3 is 9. The next one again was prime. And the last one, the cube root of negative 8, is negative 2 times 7 is negative 14. Now, do all the radicals match exactly? Then the large numbers in front, the coefficients, we just add or subtract. So 9 take away 2, take away 14. And that gives us the answer. So 9 take away 2 is 7. 7 take away 14 is negative 7. So the final answer is negative 7 cube root of 2. Number 3. All right, now's your turn. Can you add or subtract those radicals? Can you simplify it and then combine like radicals? Please try. Did you get the correct perfect fourth? 16. The next one is prime. 72. Is 8 times 9. So the fourth root of 16 is 2. And 2 times 7 is 14. The next one was prime. The cube root of 8 is 2, and 2 times 3 is 6. And what's left over is the cube root of 9. So, do you see there is two that are matching, but the one is not matching? So, which are the ones that match? 14 take away 2 is 12. They match, right? The fourth root of 3. But what do I do then with 6 and the cube root of 9? They can only just go beside each other because they're unlike radicals. Okay, try number 4. We get stronger by practicing. Those that feel they already have this skill, then that's great. You should feel happy. It's a lesson that you feel good about. So try number 4. Not everybody is at the same spot. Some people need to practice this to review. Can you simplify? Can you combine like radicals? Or are you just waiting for me to do it for you? I know you did. So you're the one I'm saying to be patient. Or you can look ahead in the lesson. So can you see if you found the right combination to simplify? Did you find 4 times 7, negative 8 times 7, and 25 times 7? Just take a moment, right? If we don't find the right combination at the beginning, right, you're not going to get the right answer at the end. So try the next step. And obviously, you have to know your times tables. And part of this is actually getting stronger memorizing your times tables, right? It's good practice with that. So, do you see the like radicals here? In fact, 20 root 7 and negative 20 root 7, what happens? 0 means you don't have them anymore, right? They eliminate. And when you add and subtract beside each other, it's really a negative 2 cube root of 7. Okay, try number 5. We got 2 more to practice, then we're going to multiply. (96) is 49 times, or 98 is 49 times 2. X to the 4th and y squared are perfect. And then negative 3x squared y root 2 is prime. So the square root of 49 is 7. What's the square root of x to the 4th? Divide by 2 and it's x squared. Square root of y squared is just y. So what's left is the square root of 2. Look first just at the radical. Does the radical match? Then what's in front we can combine together. So again, the front has to match too. X squared y, x squared. Did I do that right? X squared y. Oh, did I write this one wrong? X squared. If I wrote it down wrong, I couldn't combine them together, right? They have to match. X squared y and x squared y. So 7 take away 3 is 4x squared y, and then the square root of 2. I got to be careful that I write them down accurately. Okay, last one to practice. 6. Can you add or subtract radicals? I'm hoping the more you practice, your times tables are easier and that you can simplify them quicker. For this one, I have to write it as a to the 6th and then a1 beside it. For 135, the number is 27 times 5. 8 to the fourth we need to write as a cubed times a. So the cube root of negative 8 is negative 2. The cube root of 8 to the 6th, divide the exponents, and it's a squared. And then what's left underneath is 5a. For the second one, the cube root of 27 is 3 times the 2 in front is 6. The cube root of a cubed is a times the a squared in front makes it a cubed. And then what's left behind is the cube root of 5a. What happened?
Wouldn't it be a squared?
Which one? You're talking this one right here?
Yeah.
Instead of a cubed? So what's already in front? Is there already an a squared? And when I do the cube root of a cubed, what's going to join it is another a. So when you have a squared and another a, it makes it a cubed. Now, because of that, they don't match. See, a squared and a cubed, they would have to match for me to combine them together. Yes, tell me, Jocelyn.
But it says plus 2a squared and this says times the square root of it's not together. So you have, would it be a multiplication instead of putting them together?
I like that you said that. So you see 2a squared times, right? Do you see the one before, 3x squared y? You could write that as 3x squared y times root 2. They mean the same thing. When you see a number in front of a radical sign, it means multiplying. So that dot is redundant. It doesn't have to be there. It means that. But I'm glad that you're observant with it. Are you observant to see that you can't combine the coefficients in front? Because a squared and a cubed. So that's it. It's over. So, hey, do you remember how to multiply radicals together? If they have the same index, right? If they have, notice n would be the same index, then all you do is multiply the insides together. Sometimes the numbers are smaller. If you simplify first and then do the multiplying, then the numbers won't be as large that you're multiplying inside. So in general, I simplify first and then multiply to keep the numbers smaller, because if the numbers get larger and you have to simplify it at the end, I think that's more complicated. So ultimately, instead of going 27 times 5, how would I simplify 27 first? It's 3 root 3. Then, when I multiply this together, you multiply the numbers that are in front together. So 3 times 1 is 3, and then you multiply the insides together, and that's the square root of 15. So I try to simplify first, and then the front numbers you multiply, the inside numbers you multiply, and then see, root 15 is prime, or I'd have to do another step. So in this case, root 10 is prime. That's times, and then a negative 2 in front. Root 18 is not prime. Root 18 can be written as 9 times 2. So the square root of 9 is 3 times negative 2 in front makes it a negative 6. And what's left behind is root 2. I want you to notice when you multiply, the only thing that needs to match is the index. So they both have to be square roots to do that, but the inside parts don't have to match. When you add or subtract, the whole part has to match. Here, just because they're square roots is good. So 3 times negative 6 is negative 18. 10 times 2 is the square root of 20. Now, is root 20 prime, or can it be simplified? As 4 times 5. So the square root of 4 is, so when I double 18, it's now, and then what's left behind was 5. So again, 20 is 4 times 5. That's how I did the next step. But usually it's easier to simplify first and keep the numbers smaller. Number 9, are they the same index? Good. 9, the cube root of 9 is prime. Is there a way to simplify the cube root of negative 24? Yes. What's the perfect cube that goes into it evenly? Negative 8, right? So it's negative 8 times 3. So what is the cube root of negative 8? That would be negative 2 times 5 is negative 10. What's left behind is the cube root of 3. So now I multiply the coefficients, the big numbers in front. That's negative 20. And then 9 times 3 gives me 9 times 3 gives me. Now, is this prime or can that be simplified? How? Well, better. 27 is actually a perfect cube, right? So it's actually what number? So it's just negative 20 times 3, which equals perfect. Number 10. Simplify. Is there a way to simplify the fourth root of 64? That would be 16 times, is it 16? Or is it a perfect fourth? 4 times 4, right? 4 times 4 is 16 times 4, right? So 16, it's 2, right? And it's 16 times 4. 16 is a perfect fourth because 2 times 2 times 2, right? Times 2. So 16 times 4, we can simplify it. The fourth root of 8 is, the fourth root of 8 is prime. So the fourth root of 16, I just said, is 2. And 2 times negative 3 is negative 6. So what would happen if I multiplied these together? So a negative times a negative makes it positive 6. And then the inside part, 4 times 8 is 32. Now 32 can be written as 16 times 2. So the fourth root of 16 again is 2 times 6 is 12. And then what's left over is 2. So it's 12. The fourth root of 2. All right, turn the page when you're ready. All right, let's try these again. 6 and 8. What's a better way to write the square root of 8? So the square root of x to the fourth is x squared, and root 6 is left behind. The square root of 8 is 4 times 2, and the square root of 4 is 2, times 5 in front is 10. X to the fifth can be written as x to the fourth times x. So the square root of x to the fourth is x squared. What's left under the square root sign then is 2 and 1x. Once we've simplified it, x squared times 10x squared is 10x to the fourth, and 6 times 2 is 12x. 12 is 4 times 3. So the square root of 4 is 2. So 2 times 10 makes it 20. And what's left behind is 3x. Number 12. So I got to try 12, 13, 14. And then I'll write it down to see if you did it right. And then what happens when you have a binomial radical? That's right. So you multiply the variables, you add the exponents. Right? Good job. Right? Kids and bugs go together, you know? Butter and jam. They just seem to go together. But they seem more interested in the scorpion. The cockroach is not something they're very interested in. And you know it's an old cockroach when it has wings. You know, like when they get older, they get their wings. Did you know that? Like old cockroaches can fly. They don't crawl. Do you think you only learn math in here? We learned that a scorpion is an arachnid, right? We learn all kinds of stuff, right? Always remember that a baby, cute little baby cockroach becomes an adult cockroach. All right, so 54 is 27 times 2. And I'm going to write this as M6 and M squared. Did you do that? We're finding the number that's a multiple of 3 that's close to 8, but not over 8. That's 6. And then they have to add up to 8. The second one, 5 is prime, but m to the fourth can be written as m cubed and m. Did we do the first? And it's a good review from our last lesson. So the cube root of 27 is 3. 6 divided by 3 is m squared. And then what's left under the cube root is 2 and m squared. 5 is prime. M cubed is just m. And then we have 5m left over. So what's in front multiplies. So 3 times that. And make sure that m squared. Do I have too many 3's there? So 3m squared and m would be 3m cubed. And then under the radical sign would be 2 times 5, which is 10. That's prime. And then m squared times m is m cubed. So there's actually one more step. Do you know what it is? The cube root of m cubed is m. And if we go m cubed times another m, that makes it now m to the fourth. And what's left over is the cube root of 10. Keep going. 13, 14. I can't think of a way to simplify the cube root of 36. I don't think there's a perfect cube that goes into it. Felt like there would be. A to the 6th and b squared is fine. So, a to the 6th becomes a squared. B cubed becomes b. And then what's left under the cube root is negative 3ab. Oh, the negative can also come out front. That's important. So the negative 3, there's actually a negative 1. And the cube root of negative 1 is negative. We don't want to leave it under the cube root being negative. That negative needs to be in front. Here, the cube root of a, so 6 divided by 3 is a squared. And that's it. And we have the cube root of 36b squared. Now when I multiply the fronts together, that's negative a to the 4th and b. Then the insides together. So 3 times 36, that's 90 and 18, that's 108. A times a is a squared, and b times b squared is b cubed. Is there a perfect cube that goes into 108 evenly? And it's 27. What happened? Oh, you know why? Because I thought there's an a on the right side. Is there one? No. No a squared. Just a 36. You're right. All right, so 108, I'm going to do that in the margin. 108 is 27 times 4. So the cube root of 27 is 3. We have an a to the 4th. What is the cube root of b cubed? B times the b in front makes it b squared. And then what's left over under the cube root sign is a 4 and a. Okay, one more like that. And then we're going to look at, can you do the distributive property, maybe foiling, when it's not algebra but radical foiling. So q to the 10, I'm going to write as q to the 8 and q squared. So q to the 8th, what's 8 divided by 4 is 2. So it's going to be 14 q squared. Remember, 2 times 7 is 14. And then the inside part, so that's done. P squared times p to the 3 is p to the 5, but I'm going to write p to the 5 right away as p to the 4 times p. Q and q squared is q cubed. That's smaller than 4, so it stays the way it is. So p to the 4th and the 4th root of p, that's just p. I think that's it. What's left underneath is the 4th root of pq cubed. This is patience, isn't it, to get through that and know your times tables and exponent rules. All right, number 15 and on, we're going to have to use the distributive rule. The distributive rule is what's in front is going to multiply both. So what's root 10 times 5 root 5? That would be 5 root 50. Do you see how I made sure the insides get multiplied? And what's root 10 times negative 2 root 2? The negative 2, don't mess with it, but 10 times 2 is root 20. Is root 50 simplifiable? Yes. 50 is 25 times 2. 20 is 4 times 5. So the square root of 25 is 5 times 5 in front is 25. Square root of 4 is 2 times negative 2 is negative 4. These are unlike. So they both are square roots, but the insides have to match too. Yes?
Why isn't the 10 distributed to the 2 in front of the root 2?
So why is that root 10 not multiplying the 2 in front, right? And they are, but when you multiply root 10 times 2, that's just 2 root 10. Because 1 is an irrational number, and 1's a rational number, they only go beside each other. So what is the only one they would really multiply? See, when I go root 10 times 2 root 2, the root 10 and the 2 go beside each other, and there's still another root 2. Only the root 10 and the root 2 multiply, because they're like radicals. So, do you see how you went root 10 times this? Yes, if I do it on the side? Yes? I can only multiply what? If they have the same radical, I can multiply it. If not, I can't. Yes? That's where it comes from. Yes?
What if the 10 didn't have a radical?
So if it was just 10 times 2 root 2, then you'd multiply 2 and 10. And it'd be 20 root 2. So they have to be the same type of number. Got it? To multiply. Good question. Hey, can we try number 16? Now, what's different about number 16 is we have a binomial times a binomial. Either you are going to go first, outer, inner, last, or you're going to draw a area model to multiply this. So when you have binomial numbers, so 8 and negative root 10, 3 and negative root 10, you have to make sure you multiply it out properly. So 3 times 8 is 24. Now negative root 10 and negative root 10. One of the properties of multiplying, if you multiply the same root, it undoes the square root. So it's just 10. So what's negative root 10 times negative root 10? And the answer is positive 10. What? Oh, down here. I don't know why I put it up there. Is that happier down there? Okay, so this one would be, you're right, this one would be negative 3 root 10, and this one would be negative 8 root 10. So when I combine it together, I usually put the rational number first and the irrational number second. Though you don't have to, but normally it's written that way. 24 and 10 is 34. Negative 8 and negative 3 is negative 11 root 10. So we're applying the distributive property, foiling, but this time to unlike numbers, not algebra. So again, do you see how we're going to have to foil this? Are you most comfortable drawing a box when you foil? Yes. So let's do that. So we have 6 root 6 minus 6 root 2. We have root 6 and root 2. And again, what's root 6 times root 6? 6. And 6 times 6 is, do you see where 36 came from? Root 6 times root 6, 6. And 6 times 6 is 36. Here, this is negative 6 root 12. We'll reduce that in a moment. Here, this is 6 root 12, right? Multiply the insides together. And what's root 2 times root 2? 2. And 2 times negative 6 is negative 12. Did you follow that? So root 2 times root 2 is 2. And 2 times negative 6 is negative 12. Now combine like numbers. So 36 take away 12 is 24. 6 and negative 6, what's going to happen to them? So I don't even need, right? Why even waste my time simplifying it if they cross out? And that's it. Nothing left. The answer is 24. Hey, how do I square this binomial number? Again, I'm going to have to But it just means that 4 subtract root 5 is on the top and on the side, right? Can you multiply this out? That's 16, negative 4 root 5, negative 4 root 5, and negative 5. Oh, because a negative times a negative makes it, you guys are so smart. 16 plus 5 is, and then negative 4 and negative 4, they don't cross out. Don't pretend I didn't do that. That's negative 8 root 5, and that's prime. Done. Number 19, I don't need a box. I just need to multiply it properly. So 3 times 12 is the square root of 36, and it's k squared. Do you notice the negative 2? That has to stay in front. What's 3 times 15? And k times k squared is k cubed. Can I simplify this? Well, the square root of 36 is 6, and the square root of k squared is k. Here, 45 can be written as 9 times 5, and k cubed can be written as k squared times k. So I have 6k. The square root of 9 is 3 times 2 is negative 6. K squared is just k. And what's left underneath is 5 and k. They are not like terms. If you're in the mood, you could factor out the 6k, but that's not what we need to do. All right, number 20. For number 20, we need to foil. So can you set it up in foil? Then I'll do it. Let's see if we did it right. So again, I'm going to let you do it first. This one's kind of tricky, right? It's the square root of 8x. So you multiply the two insides together, right? This is the square root of 2x underneath. And then, what is 2 times 8? And the square root of 16 is, so can you see where the negative 4 comes from? So, right now, it doesn't look like I have anything that can combine together. But, do you see the square root of 8? How can I write the square root of 8? As 2 root 2, right? So the square root of 8 is that. I have a plus root 2x and a minus 4. We actually can combine the two middle ones together. So we have an x, negative 2 plus 1 is negative 1, root 2x, and then negative 4. All right, last one for the lesson. A little geometry reminder. Find the area and what? Of a rectangle. So reminder, area is length times width. What's perimeter of a rectangle? Twice the length plus twice the width. So for the area, what am I going to multiply together? 4 minus root x and 7 root 6 plus root 3. For the perimeter, I'm going to go 2 times, and it doesn't matter what's the length and what's the width, and then plus 2 times, and then can you simplify it? So length times width, twice the length plus twice the width. Just for fun, I'm going to FOIL. So first times first would give me 28 root 6. First times outer would give me 4 root 3. If I multiply inside together, root 6 times root 6 is 6, and 6 times 7 is 42. And root 6 times root 3 is 18. 18 is 9 times 2, so it's 3 root 2. There are nothing that are like that I can combine together. It's all prime and nothing combines together. That is the area. How about the perimeter? 2 times 4 is 8. 2 times negative root 6 is negative 2 root 6. 2 times 7 is 14 root 6. 2 times root 3 is 2 root 3. We do have like terms here, right? Like numbers. So the 8 is in front. What's negative 2 plus 14? That's 12 root 6. And then we have a 2 root 3. Everything is prime. Nothing that we can simplify or combine together. All right, that's your lesson. Adding, subtracting, multiplying, even a rectangle. Mr. G Math, over and out.